Hello, my name is Hisham Gaber, and today I'll explain and present the paper with the title Speeding Up Distributed Machine Learning Using Codes. So here's the outline. First, I'll begin with the motivation, then what's the challenge and what's the objectives of this paper, and then what's the proposed method or technique to overcome this challenge, and the key contribution, which is mainly two things: matrix multiplication and coded shuffling, coded matrix multiplication and coded shuffling, and it compared them with the uncoded. And I will emphasize on what's the major innovation of the paper, and then we'll present the results, and then conclusion and future work. So the motivation is now there is available distributed systems became very large, massively large distributed system, and these systems are required to be robust against noise. So the challenge is the noise. The noise affects the performance of the system, and this leads to staggler nodes, which nodes that significantly slower than average. It's very slow nodes, and system failures and communication bottlenecks. So next slides we'll see how to overcome these challenges. So the objective is to provide theoretical insights on how coded solutions can achieve significant gains compared to uncoded solutions. So this present a coded solution and compare it to the uncoded. The two main techniques, as we said, is matrix multiplication. Matrix multiplication will reduce the effect of stragglers, which speed up the system. So this will address the speed. The other thing is data shuffling. Data shuffling reduces the bottlenecks and the excess storage. So this reduces the cost. So the paper will present a technique that speed up the system and reduce the cost. Then we will provide the experimental, or the paper provides the experimental results that shows like this gains, like prove that this technique or this method is really proven to be very efficient. So the proposed method contains three phases. Phase one is the storage phase, where the data input data is distributed over several nodes. Then the middle stage is or the middle phase is the communication phase, and the final is the computation phase. The function delta is computed locally at each distributed node. We'll see in details in next slides every stage, especially the communication and computation phase. So the two core blocks of the communication and computation phases are matrix multiplication and data shuffling, which, as we said, matrix multiplication for speeding up, for addressing the straggler nodes, and data shuffling is for reducing the cost. So first, matrix multiplication. So we have we will discuss first the left-hand side. We have matrix A will be divided into A1 and A2 and A3. A1 is stored in node W1. A2 is stored in node W2, and A1 plus A2 is stored in W3. Next slide, we will discuss this part, the right-hand side. So after receiving after receiving the data, the input data, it will be multiplied by X. So A1 will be multiplied by X, and A1 plus A2 will be multiplied by X. And send the product to the matrix, to the master node. The master node will recover AX upon receiving any two products. So no need to wait to the slowest response. So we only need to wait to the first two, the fastest two products. So as we said, this will speed up the system. The second technique we said is coded shuffling. As we said, coded shuffling is to reduce the cost. So there is matrix A. A will be partitioned to 4 submatrices, A1 to A4. So before shuffling, the worker W1 will have A1 and A2. The worker W2 will have A3 and A4. The master node now can send A1 plus A3, and in order to shuffle the data stored at the 2 workers. I also want to emphasize the major innovation. So the major innovation is this will lead no need to refactor code and modify the system to accommodate for our solution. So the system already implemented. We don't need to like manipulate the system. We don't need a code, a certain special code, or modifying the structure of the system itself. All is done seamlessly in the algorithm design layer. And this abstraction is much more impactful. It's located in the hierarchy, in a high level of the hierarchy, and it's much better compared to the traditional application of coding. Traditional application of coding needs to interact with stored and transmitted bits. Now we discuss the results. So the results, as you said, our goal is speed and cost. So these results represent the speed, like calculating the speed with different multiplication algorithms. So we have like 4 graphs for 4 multiplication algorithms, block and call and draw and coded. So the first 3 is uncoded and the last is coded. As we see, the coded performs better. The average runtime for the coded is better in all the 4 graphs, much better. The next step is we will calculate the average of the uncoded and coded. So we like see the final result. Here it's the final result. So computing the average speed. So the blue is uncoded and the yellow is the coded. As we see, all the coded performs much better than uncoded with runtime much less. In terms of cost, so we evaluated the MPI broadcast and scatter. Like the average time for MPI is much lower. So the cost of coding shuffling is much smaller than uncoded shuffling. It requires much less storage. As we see, number of receivers is much less in the MPI broadcast than the MPI scatter. So this will significantly reduce the cost. So to conclude the paper and suggest some future improvements or future work. So the paper itself explored the power of coding, the coding algorithm, and this coding will make the distributed systems robust to noise. The paper also proposed a novel approach, which is coded computation framework. It proves that this approach can significantly speed up the distributed algorithm or the distributed system. There is still some future work. So the 2 algorithms proposed, we can use another algorithm, not this basic matrix multiplication. We can use instead of basic matrix multiplication, we use a broader class. For shuffling, we can find some information theoretic lower bounds on the rate of coding shuffling. So we can improve this coding shuffling. Thank you very much for listening, and goodbye.